Identify and evaluate exponential functions. The goals for this lesson is to identify exponential functions, evaluate exponential functions, and calculate continuous growth and decay. Now, exponential function growth refers to an increase based on a constant multiplicative rate of change over equal increments of time. That is a % increase of original amount over time. While an exponential decay refers to a decrease based on a constant multiplicative rate of change over equal increments of time. That is a % decrease of original amount over time. In general, the exponential function is given by this expression here, where a is any non-zero number and b is a positive real number not equal to 1. Now let's consider the following functions here. Let's identify which of the following functions is not an exponential function. Now, to review, an exponential function is generally of the form f of x equal to a times b to the x, where a here is any non-zero real number, and b is a number greater than 0, that means positive, and not equal to 1. So these are the restrictions here. A must not be equal to 0, because if a is 0, then this is just f of x equal to 0. And then b, the restriction for b is that b has to be positive, but not equal to 1. By looking at each of the functions here, see which ones here does not satisfy this criteria. For the first one, e of x is equal to negative 3 to the x. In this case, the base here, this number here is our b, that is negative or less than 0. That means that this function here is not an exponential function. So this is not an exponential function. Now, f of x equal to 2 to the x. The base here is, the base b here is equal to 2, which is greater than 0, not equal to 1. So this is an exponential function. What about this? H of x is equal to 1 to the x. B is equal to 1. So therefore, this is not an exponential function. And next, I of x equal to 5 to the 2x plus 1. The base is greater than 0, not equal to 1. Therefore, I of x is an exponential function. To evaluate an exponential function of the form f of x equal to b to the x, we simply substitute x with the given value and calculate the resulting power. And to evaluate an exponential function with a form other than the basic form, it is important to follow the order of operations. Now, suppose, for instance, we want to evaluate our function f of x equal to 5 to the 2x plus 1 at x equals 3, or we want to solve for f of 3. So to solve for f of 3, we are just going to replace our x here by 3. So we substitute x by 3 and follow PEMDAS. So raised to 2 times 3 plus 1. 2 times 3 is equal to 6 plus 1 is 7. This gives us 5 to the 7, which you can simplify to be equal to 78,125. Next, if f of x is equal to 22 to the x minus 1, solve for f of 10. F of 10 means you evaluate the function at x equals 10. That means you just have to substitute x here by 10. So replace x here by 10. So you have 10 to the 10 minus 1. So therefore, we have 22 to the 9th. And then just simplify it using your calculator. So in general, these are the formulas that you would easily find in most applications. So this a sub t here equal to a e to the rt is the formula that you use for continuous growth or decay. So for here, this is just an exponential function. The r here in the formula is called the continuous rate per unit time, and that would also determine whether you have a continuous growth or a continuous decay. If r is greater than 0, the formula represents a growth, continuous growth. And if r is less than 0, negative, the formula represents a continuous decay. A here, the coefficient A is the initial value, and that is just a constant, and t is the lapse time. T here is the lapse time, and A is the initial value. The initial value is the value of A when t is equal to 0. Now for business application, the continuous growth formula is called the continuous compounding formula. So the continuous compounding formula is given by this. So P here is the principal or the initial amount invested, and the rate R is the rate of growth or the interest rate per unit time. And T is the period of term of investment. Now we will follow the following steps here to solve a continuous growth or decay problem given the initial value, rate of growth or decay, and the time t. So the first step is to use the information in the problem to determine the initial value A, and then use the information in the problem to determine the growth rate. If R is greater than 0, we know that to be a continuous growth problem, and if R is less than 0, that is a continuous decay. And then we will use the information in the problem to determine the time t, and then we will substitute it to the formula for A of t. So to apply this, let us consider the following problem. You invested $2,000 in an account earning 5% per year compounded continuously. How much was in the account after 5 years? So the first step to solving any word problem is to identify what is given. Here we are given 2,000, and 2,000 is the initial amount invested. And then 5% here is the rate. This is compounded continuously, so we know what formula to use. And then we want to know how much is in the account after 5 years. So that gives us also the time. Now identifying the given here, this 2,000 here is our P, and the 5% here is the rate, and we will write the rate in decimal. So we convert 5% to decimal, that is 0.05. Then the 5 here is the time. So t is equal to 5. P is equal to 2,000. Then looking at the formula for the formula for our exponential function, exponential growth or decay, or continuous compounding interest formula, we have A of t equal to P times e to the RT. And substituting all the information that we have, P is equal to 2,000. That's how we have P here. And then the rate, which we converted to decimal, is 0.05, is in here. Replace the R there by 0.05. And the time is 5. That's how we put the time here. Then we would then compute this using our calculator, and that is equal to 2,568. Next example. A substance decays at a continuous rate of 24.5% every day. How much will remain after 8 days if you start with a 50 gram? First, let us identify what is given. We're given here 24.5%. That would be our rate, our R. And we will convert that to decimal. And then we have 8 days here. That would be the time. And it says here, if you start with a 50 gram, so that means that 50 is the initial condition. Now that we have identified all the given, we are able to identify that this is an exponential problem. So we are going to use the formula here. A of t is equal to a e to the rt, where our rate r here is r. We convert that to decimal. That is 0.245. And then, since this is a decay problem, that would be negative. And the time here is equal to 8. And the initial condition A is equal to 50. So then you plug it into the formula here. You replace R by negative. That's how you have a negative number here. And then this value, R equal to negative 0.245, will be replaced in the R here. So evaluated or substituted to R. And then the time T is substituted to T. And then 50 is for the initial condition at A. Then simplifying this using your calculator, this is equal to 7.04 grams.